So welcome to this session on intermediate Linux. One of the things that you are learning is in the world of HPC, being able to uh, work in the Linux environment is somewhat of an essential for a lot of people who need to get onto the computer and do some kind of work. And so there are applications like gateways where you don't need to get on the computer, and if you can work through the Expanse portal, then you're very lucky. You don't need to get on the computer and deal with Linux. But we do appreciate quite seriously that for most of you who are here today, this is very challenging environment, and you need to get onto a system like Expanse or Voyager and work from the command line. It's just a reality of high performance computing, and it's unavoidable. So this talk is a bit part of the complex program, and the complex is comprehensive learning for end users to effectively utilize cyber infrastructure. And it's a new approach for teaching and training, where we focus on people who need the entry level materials. You're doing really advanced scientific computing, but you need to get onto these machines and learn how to navigate them. So that's the focus of them. So I have an outline. It looks like a whole lot of sections, but I organized it topical so you could come back and find it later in time. But this is just a few of the topics that we assume you'll need to know. So again, this is for the Linux environment and people who want more skills. There is this baseline that we assume you're already able to navigate, and if not, I'll share a link to a GitHub repo that we have for learning to do basic commands on Expanse in particular, but on HPC systems. So I just want to point out that in the Linux world, intermediate is in the eye of the beholder. What we'll be teaching you today for a really advanced system administrator that manages, hundreds of racks in a machine room. This is pretty basic stuff, but we appreciate again that it's a big challenge at the beginning. So everything in here is the list of skills that we feel you should try to master or at least become familiar with as you work on these systems. So, and it's okay, we appreciate that. We all had to go through that learning. So again, we assume you already know some basics, and if not, you can go to this basic Linux skills on Expanse, get an Expanse account, which you can do, and try them out on that machine so you can get a feeling for what it's like to navigate, so listing, navigating, removing file contents, paths. And so here's a few links that can help you get familiar with what we consider to be the basics. And so this next section is any questions on the introduction. So what I'll probably do is as I go through each section, I'll stop and see if there are any questions. Or you can enter any question into the chat. We have a team of people that are part of our staff that will answer your questions as best they can, and then if not, somebody can ask me what I meant when I said something. But go ahead, this is your chance to learn and take advantage of us being here. The file system hierarchy, so knowing where files are stored and knowing what is a file in Unix is very important to learn. So it's the conventional layout of a Linux system, and in Linux and Unix everything is a file. So you move files through and move them into different folders on a PC, but we call them directories in Linux, and files are places where data goes. Some files are obviously data stored in a file on the drive, and some files are places where you pipe and send output from one command to another. So it's a simple concept once you get it, but it does take a little learning to get used to it. But the basic files are lib, bin, user lib, and user bin. So USR is user. So there are these basic distribution files, directories where files and libraries go, and they're pretty common on a Linux distribution. Somebody, like if you have your own Mac OS PC, you may add something or make a folder or file that you want to customize, and that's okay, it's your environment. But in general, you'll find these standard distributions. And so most of us don't need to worry about that. That's the job of the sysadministrators. But they do a lot of work to make sure a library, application library that you need is in the right directory so you can find it. And so we'll kind of go over some of that. And then there's a few links for you to go and learn a lot more about it. For example, if you're installing your own software, why would you put it in /lib, or should you put it in /userlib? You might wonder about all of these, and it really is up to the local site and the system administrators. And my MacBook Pro is my local site, and I'm the sys administrator. I can put things where I want, but other software might not work if there's a dependency. The areas that you might look at most often are your home directory. This /home contains user directories, so if you have an account on Expanse, I would be /home/mthomas. And the slash is a separator. On PC, it would be \, but under Unix, it's a /. And there's /bin and user bin, and those usually have applications and binaries and commands that you're going to learn or you're learning as part of the basic skills. And sbin and user sbins are really sysadmin type of commands, and many of them you might not even have permission to execute. There are some folders or directories on a Unix system that you don't even have permission to look into, and those are owned and internal, and they don't want users like us mucking around in there and messing things up and executing things we really shouldn't. So /user, /lib, and /userlib contain libraries that are needed by the Unix commands. Sometimes they're the same. And /opt is where software is often installed, but we use package managers like one called SPAC, and SPAC has its own way, and I'll show you some examples of how software looks that's installed on a large machine like Expanse. Etsy contains configuration files for the shells and schedulers, networking accounts, and package managers. /root is the home directory of the root user. On some systems, you may not even have permission to look down in it. You certainly couldn't go into the directories. Those are powerful directories with a lot of management applications in it. /var are log files, and often you can look at them to see the log files maybe of an application that you use. An example would be web page log files. /dev are the device files, like when you log in, you're coming in through a device, which is a connection. /proc and sys are pseudo files, and they have information about the processes that you're running, the hardware, and other configurations like that. /temp stores temporary files. Nothing's guaranteed. /temp files on a system like Expanse may last a month, or they may have to clean them out every night because a lot of people are using them temporarily. So /temp is don't count on it, but you can use it intermittently. And not everything fits into the FHS, the file hierarchy system. And this can be additional files and softwares that you're installing yourself, or package managers. And for example, on Expanse, we have the Lustre parallel file systems. They live in their own directory system, and Expanse, Lustre, Scratch. So projects is where you'll have, if you have an account, you'll have some storage space in projects, and you'll also be able to use Scratch. And Scratch is like temp. It doesn't last forever, and it will eventually, your files, if you count on that to store your data, you might lose it. So we do recommend that if you're running jobs, you can put files into your home folder, but that's limited. We'll talk about that in a moment. Or you should either move things to Lustre, where it's more permanent, or to some other offsite storage facility where you know you need to archive your data. Cumulo is a cloud storage, and it's mounted on Expanse projects. And software installed with SPAC are found under /cm shared apps SPAC. And there's a lot of files and example files and libraries and compiler libraries are in this folder here. And our sysadmin people and our user support people work really hard to make sure all of this is coherently installed for all the different compilers we've got, for example, and the different versions of compilers. Is pretty complicated. So symbolic links, are there any burning questions under the file system hierarchy standard section? We have people answering them. Cindy, are we good?
Yes, you can proceed.
Okay, great. Symbolic links and hard links. This takes a little while to wrap your mind around it, but you might have something that you've installed or somebody else has installed, and you're working in a directory where you want to have it locally available to use, so you make a symbolic link. So they symbolic link refers to a file or an inode, which is a file data structure. And you can give it a different name, and they're helpful when you want to avoid writing out a very long path like that /cm share da 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 da. It could be very long, and I hope I have time to show you real examples of how long those are. So you could alias it, basically. Think of it as an alias, and you can put it into a directory, and you can use multiple aliases, and you can have it in different directories. The only challenge is you have to make sure that what you're linking to is still around if you've taken a few months break from that particular directory that you're working in. So we'll show the difference between symbolic links and hard links in the next couple of slides. But here's an example. LN stands for link. And in Unix, if you'll recall, if you want to know about a command, you can do like ln-h for help, or a man page might exist. So the man command, man space ln will give you, if there is one and if it's installed, the man page. But to first order, ln-h or -help should give you information on a command. So this one here is creating a soft link between soft file and file 1. And here we're making a hard link between file 2 and hard file 2, and I'll show you examples about that. So symbolic links. An inode is a data structure that stores information about a file. It has permissions, file size, ownership, timestamps, and location of data. It's a link to an inode, and hard link is just another file that links to this inode. The inodes are only deleted, and so normally you're not looking at the inode information. It's just part of when you do a listing of what's in the directory. It's only deleted when all the links to it have been deleted. If the original file gets deleted, the data can still be accessed using that hard link. A symbolic link is another name for the file. If the original file is deleted or removed, the symbolic link still exists, but can't be used to access the data anymore. So here's an example of we're in a directory, and we look at the files, ls. I have file 1 and file 2. And I do a link file 1 to file 1-hard, and then ln soft, file 2 to file 2 soft. So file 1 and file 2 are the original two files, and then these are basically the aliases, the symbolic links that we've created. And here we're looking at inode information on file 1 and file 1 hard. Notice those have the same inode number. And file 2 and file 2 soft, those are different. And that's how you get the idea that if you deleted file 1, the file 1 hard information will still be there. If I remove file 1 and file 2 and I try to cat the contents of the file 1 hard, I get some contents. And if I cat the soft one, though, it's gone. So you can permanently make a permanent inode link for that file 1 hard. So these examples, by the way, are in a GitHub repository, which The link was at the top of this talk, and I'll show it again. So you can practice all of these from a README file and copy and paste it into the HPC system, or even your laptop if you have a terminal window. You can practice all these, and that's the whole point of these examples. Is there Bob's mentioned this before, the complex material is system agnostic. It's just the basic stuff. It all works on Expanse, but you can do it on your laptop if you have a Unix, Linux-based terminal. All right, so you generally work with these symbolic links since they let you span different file systems, and you can create them to files that maybe don't even exist yet. So here we have a file 3 and a file 3 hard, and this one, file 3, doesn't exist. Then I make a soft link, and then here I'm making an example of a long link, a long directory location, and so file 4 hard. And here I had trouble creating that file 4 hard link because there's an invalid cross-device link. So where is that file 4? Here's file 4 here and file 4 soft. So we're having some trouble getting these linkings, but we're making temporary links that eventually will link a file to. So now I do an ls, and they're all showing up in the folder because I've created a cross-link. Any more questions on redirection and pipes? Until you play with them and you get in there and you handle them and you look at the contents, this is something that you might want to spend some time playing with. Are we good, Cindy?
Yes, you're good.
All right, so redirection and pipes. So, creating these soft links is in a way a redirection, but redirection and pipes are really core to basic Unix and why people like to use Unix. So the commands are basically structured to write to what we call standard output. When you're working on a terminal, what you see is WYSIWYG. What you see is what you get. I do date, and the date will show, but I can redirect the output from date, which is a command, to a file called outfile, and cat the contents of outfile, which is what you would get from the date. So we're taking the output from a command and redirecting it into some other Unix file, which in this case is a physical file. And cat means, print out the contents of this file called outfile, and there it shows up. So we're taking output from one command, piping it into something else, which is a redirection command. And that redirection, the right arrow, says write whatever's flowing into this command to a file called outfile. And so here I do date again, and with a single arrow, I overwrite the contents, and we get a different time, 20, 25 seconds. But if I use the two right arrows is append, then date will be appended to outfile, and I'll have two different times in there. So you have to be careful if you're doing a script and you're redirecting output to files to make sure you want to be sure, am I writing to it and overwriting, or do I want to keep appending to it to sort of get maybe some history from a command. The pipe is another command that literally says pipe the output from a command and put it into a new command, and that new command can do something else. Sometimes when you're doing a big file search and you're trying to look at lots of information, you might have multiple commands all piped together where you're doing 5 different things, and you'll learn how to build those up. And so the pipe command explicitly says take the output, the standard out from one command, and direct it into as the input to this other command. So here's list the 3 longest running jobs on Expanse on node exp-2-09. Expanse, there's multiple nodes, as you know. It's you have a login node, but also you can log on to a node if you're running an HPC job on there. So SQ is the Q command. I'm running that from the login node in this example, and I'm using pipe the output from the SQ command to the grep command. And grep, it just looks at its input and looks for any string that you want it to look for. In this case, look for the name of this one node, expanse-2-09, and just give me the top 3. So I'm piping it again to a command called head, and show me just the top 3. And this is the job number. This is what queue system the job is running on. That's the name of the job. This is the owner. It's running. This is how long it's been running, and this is where it's running. So it's very powerful when you can start concatenating these different commands to get a lot more filtering and information that you might need. Again, standard in can also be redirected. So when you're on the command line and you're typing into what's called standard in, and standard in takes that and does something with it depending on your command. So here I'm doing word count -list and look at what's in this file. So in the previous command up here, we printed out the contents of that file, and out came the contents of the file. So down here, we're actually saying take the contents of this file and make it as the input to word count. And it tells us that we have 9 words or characters in that file. This is -L and the contents of that file, the name of it. We can also pipe that into the cut. So we just look at one line and out, or the first output from word count, and out comes the number 9. And now we want just the line count, which is 9 lines. So you can do different things with these different pipe and redirection command. Okay, so that was redirection and pipes. Cindy, are we good?
Yes, we are good.
All right. Wildcards and globbing. These let you express a pattern for matching multiple file names using any combination of the following. A question mark matches any single character. A star or asterisk matches any string, including the empty string. And left bracket ... right bracket matches multiple characters or ranges. And this is part of what's called a regular expression pattern in Unix, and it takes a while. It's something that I'm very weak at. I admit it right out the gate, but it's an operation that you learn to use, and it does become quite handy. So go and look up globbing and get some examples and play with it, because that'll be very powerful as you're again trying to find. You have a application that's running and you have hundreds of output files, and how can you tell which one has the data in it that you need? And you can do globbing on many of the Linux utilities that operate on files, including ls, which is file listing, remove, that means delete the file, move the file from an old name to a new name, or an old folder directory to a new directory. You can cat out the contents. Head, tail. Remember, head just grabbed things, lines of data from the top. Tail will grab lines of data from the bottom and from the file command. So here we have a bunch of files that we've set up as an example. And if you download the GitHub repository, you can get all these files. So you have all the examples. But here we have, about 12, let's see, 4 times 20 files, right? And they have different endings and different beginning names. The text and executable in these examples, or DAT. The name of the file, if you're making your own, it's really up to you. And whoever put these examples together chose to call some DAT. There's no real magic to it, except for some applications may have a preference for the file extension. But because it's Unix, you can do what you want with it. It's up to you. But it makes sense if abcde.txt is text. It should just have text in it. this AXCDE is an executable. It probably should do something and be some kind of compiled binary. And then data might be where you send your data. But sometimes people call it file2.out, file2.data. I mean, it's up to you really what you want to call things. And you, unless you're running an application and then the application developers decided what it should be called. So here we're listing, list any file in this example, any file that begins with file. So the asterisk says files whatever after that. So we have file1, file2.dat, file3.dat, file4, file c.dat. So file names beginning with file. And now we'll look at any file that begins with F. And so that pulled in ls f star fgij. So we're not just limited to file. So you got more file information, or filtered out. We're filtering out as well. Whoops, sorry about that. And then finally, list any file. Here we're using the asterisk at the beginning and the end. So any file that has the string GHI, and that's EFGHI, EXGHI, and GHIJK. And notice there's .text and .exe. So you have a lot of control over what you're getting. And this allows you, if you're like printing out hundreds of output files, like, or you have hundreds of images that are coming from your application, you could search and find the ones with a specific file name characteristics that are important to you. So that's globbing using the star, and now we'll use the question mark. There's our files that are in this one particular directory. And now we're looking at file question mark .dat. So we have file plus any character ending in .dat. So that's file 1, 2, file 3. It's very similar in this case, but here we get file AB and file C. So anything that has file in it. And now we're looking at anything that, anything beginning with an A with any characters CDE dot star ending in anything. And that pulled out 2 files. And then here, anything with any characters, question mark, X question mark. So we have to end with 3 letters and have 1, 2, 3, 4, 5 beginnings. So this pulled out any file that has an X in the extension, and then this pattern of 5 letters in front of it. So you can get real specific, and very powerful to be able to sort your data. And now we're looking at the brackets. So this allows you to define particular kinds of strings that are in there without using the question mark and the asterisk. Here, this first example, find matches that use have integers 1 or 3, and this was a range of integers 1, 2, 3. So notice there's file 1 and file 3 here. And now if you do the range of 1 through 3, you get file 1, file 2, and file 3. So we pulled in one more file. And then multiple matches using AC X star dot star. So it has A and C, and then D E X E and C X E F G. So we've got C in here. So it's like an or, A or C, with an X in the name as well. So you can get all kinds of matches on these. And here, multiple matches using a range of letters. So A, B, or C in the name with an X as well. All right, so next we'll go to aliases, unless there's questions about wildcards and globbing.
No questions at this time, Mary.
All right, great. Aliases, they're just short cuts for Linux commands. I use alias all the time. I love it because instead of typing 45 characters, I alias a command. But you want to be careful. A lot of people alias the remove because since you can glob things, I'm using stars in some of these examples, you can glob your aliases and end up removing all of your files. So there's a way to alias remove so that it always asks you, are you sure you typed remove space star? Are you sure you want to remove every file in the directory that you're currently in? So it will force remove to the command to ask you. So, remove, if you alias it, and then you type the command which will first of all find out if that command is in your Unix path, and by now you should know what a Unix path is. If not, we can answer that later and show examples. But it tells you that a remove is in your path, and you've made an alias for it. And so sometimes something you'll learn about as you work on Expanse, or for example, we have these modules that you can install to build your customized environment. And one command might be in one module, but it might not be in another one because you're not running that application, for example. So you have to know what's my environment, and if you're looking for a command and you can't find it, you do a which command and it will tell you information about that command or tell you it's not in your environment. So here we're abbreviating a long command. That's a very long command that looks at running a command called sinfo. Here's the output, and then the different components of it that you want to grab. And it's telling you where to get this information and how to format it. So here's the alias. It shows sinfo with all of this information, and that sinfo is in CM shared app slurm current bin sinfo. If you weren't using slurm and didn't have it in your environment, you wouldn't be able to find sinfo. And then here's the file listing. For me, I use ll command. I love to see how old a file is and a direct listing. So you can alias ll to be ls-al, which will tell you the file access permissions for user, owner, group, and world, and then the name of the group it's in, or the name of the owner, the name of the group, how big it is, and the last time it was accessed. So aliasing LL is, for me, really powerful. And then you can alias them all the aliases. When you log in, you might have a few aliases that are provided by the system. So when you log on, type alias to see what's aliased. One of the things that's happens a lot is VI is default alias to color, and so I unalias it because I don't like color in my editing environment. So again, you're moving towards customizing your environment, but you will be provided with aliases that the sysadmin people, for example, find commonly used by people and popular. Okay, and I always end up with like tons of aliases, so and those can be you can put them into your .bash rc file. Depend on your environment, what you want to put. You can put I put them into a separate .alias file, and I launch that when I log in. Command history. It's really important to know what you've done. Any questions on aliases, Cindy?
No, Mary, you're good.
Okay, great. Command history. You can inspect your history using a command called history. And history will tell you however many historical commands you've run that you set up in your environment to keep. It takes up memory, but you can keep hundreds and hundreds of history commands. And those are useful for when you're doing a lot of work and you want to go back and say, what was I doing 20 minutes ago? That command worked. So you can see your history, go, okay, there's the command. I'm going to get that one back and I'm going to undo what I did. Or it gives you information about what you've been doing. For example, all the commands I showed you before, if you're practicing that on a Unix terminal and you type history, those will all show up. And if you say, you can set your environment to limit the number of history commands you keep, 500, 1,000, 20,000, and you can store, there may be a limit set by the OS or the sysadmin people, but you can save all those. And it can be really important when you're in a very serious compile, debug, run, change configurations, update my input files if I'm running an application. So you can go back and see what you did right, or maybe if you had a problem. So get to know history, it's your friend. So here we're just typing the history, and snip means all the other lines above it. As a demonstration, I've just cut them all out. That's a common term, but it does show that you have 430, and the last thing you wrote, you typed was echo hello, or list file, or remove a file. So you can also execute the last command that you ran with the exclamation point. So if you did an ls and it was the last command you did, you can repeat it, and it will echo the command that you had and print out the files. Very handy when you got a really long command that you're playing with and you haven't aliased it. You can just recall it. You can also, along this thread here, if you know that line 428 was a command you wanted to repeat, you can use exclamation point, repeat the command in the history file that's number 428. Very, very powerful to get to know that as well. And then executing the last command, you can do the exclamation, and it will repeat that command. And I'm sorry, this command here will find the last time you used ls and repeat that command. You can actually make this a very long regular expression if you're trying to find one that you can't find quickly in your history. Okay, so with no questions on command history, we'll go to navigating between directories. We're doing great on time here, I hope. Navigating between directories. There's different ways to do it, and if you're familiar with Windows, it's similar, but Unix does have this concept of push D and pop D, where it remembers where you came from, like if you're changing to multiple directories, and can help you go back to a directory without having to retype long commands. So if I can get through this, so push dir1, and it shows you that you were in ppdem. Well, tilde means your home directory, if you don't remember that from basic Unix, and tilde ppdem. And then push d dir dir2 shows you that you push D with directory name adds to the top of the stack, so you're putting that in the stack. With no args, it swaps the top two directories. And then push D plus N brings the nth directory to the top. And you can CD into that directory. You use CD to move directories. Pop D with no arguments pops the top directory, gets you into that one, and dirs lists the directory stack. And so I don't have, here's dirs that shows you have 3 directories. And pop D moves it through and moves you through the directory stack. All right, so environment variables. These are really important. The shell and environment variables, let me make a note here. The shell and environment variables, this is how the Unix system knows who you are, how you know where you are, how you know what you're allowed to do. There's different shells, so commands might be a little bit different. There's bash shell and T shell and Z shell, and every few years we get a new shell. And the shell variables are only known within the current shell that you're in. And so you can have commands that run under a different shell, so you have to make sure you have the right environments in the shell of that command. And so environment variables are known globally and are inherited by the processes and shells that you launch from the current shell. More often than not, you'll probably want to use the environment variables wherever you are rather than these shell variables. And when you're launching jobs, say to the batch system, you want to make sure you're propagating important environment variables into the script that you use to run a job. And we have a whole session on running jobs using the batch queue system, but that's an example of where you'd go from the shell you're in and get put into a new environment when the job is running, and the job needs shell and environment variables that are critical to the job you're trying to run. So it's part of the complexity of the layers of an HPC system. Where are you currently? Where's your job going to run if you run it through the batch queue Where will it run if you're doing interactive computing? What's the environment you inherit in those two different places in the system? If you're submitting a job to the batch queue, the job will run behind, sort of in the background while you're having coffee, but it's got to have a right environment, and the variables that you needed the job to have, you have to propagate those. And if you go into the interactive node and there's environment variables you need, you can pass them into it or you can redefine them. Everywhere you go in the Unix environment, you need to be aware of the shell and the environment variables that you have within that space. Is one, it's probably a better word for it, but where you are currently at. Either inside an application, like if you launch MATLAB, or if you launch a notebook, you're in the notebook environment. The Jupyter Notebook may not inherit the environment variables that the application you want to run. So you have to make sure you get the environment variables into the environment you're working in wherever you are. Sounds really complicated, and it can be. And so things you might launch a job and go, wait, it worked when I did it on the command line. Oops, I didn't define a particular variable that is used by my application. So you have to learn how to propagate this information. But first you have to know what they mean. So the shell variables can be set using the key equals value, and you can concatenate more than one value. Syntax, space is not allowed around the equal sign. You can pass shell variables to like the sbatch command or other Unix commands. And they're made into environment variables using the export command as well. And the values of the variables can be accessed using $key or any other shell variable. The dollar sign will extract the value, so you can also do like echo $key. So here are some examples where we're setting key 1. They don't have to be called key. You can call them whatever you want. Blah, blah. But in this example, we're using key. Key 1 equals ABCD. Key 2, EFGH. Export key 2 makes it an environment variable. Export key 3 equals IJKL. Sets up the value for key 3 and makes it an environment variable. Echo $key 1 gives me ABCD, echo $key 2, echo $key 3. Now these are all environment variables set in the shell that I'm currently in. And now I'm going to launch a new shell, /bin bash. Echo $key 1. It doesn't exist because it didn't get, it's just an environment variable. But echo $key 2, which is it was exported, it's an environment variable. It was passed on to the new shell that I launched. And the same with $key 3. So that's an example of how you're creating a variable that gets exported when you launch a different command. Now, if you were to go into bash and then launch another shell, these may not propagate. So you need to be careful how your variables propagate. So another way to assign these environment variables is with declare command and the -x flag to export. And the -r is to make it read-only so it can't be changed. So declare var1 equals ABC, declare -x will export the environment variable, which we can see var1 did not export, but var2 did. All environment variables can be displayed using the env command. So this env, this is just a partial. On a really big system like Expanse, it can be 100 lines long, especially if you're creating a lot of, using a lot of applications that you've loaded into your environment, like for MPI compiling in Fortran and C, and you want to run jobs using Slurm, you can end up with a lot of environment variables. But getting to know what should be in there and what's in your library path and man path, your login name, your shell, your home directory, these are all really important, and you actually can end up using these shell environment variables in your in scripts that you might write. All right, configuration files. These are very powerful. Any environment variable questions, Cindy?
No, not at this time.
Okay, great. Or burning ones. I see there's been a couple things posted, but Linux configuration files. So when you log on, you have to get set up. The operating system needs to know who's SSHing onto my system. So you have to give it your login name. Like for me, it would be M Thomas. For Bob, it's think of it. So you have a username, and it knows for that user to get some default environment variables that get set up by the operating system management people /etc profile etc bash rc and .bash underscore profile. They each do different things, and you can look at them and see what they do. So you inherit those by default when you first log on or when you first launch a shell. And then you can add scripts and source codes that apply to your login shell or that you want to run. But usually you can put customized environment variables. We recommend that you put them in .bash underscore profile and put aliases and functions in .bash rc. The .bash rc will launch the .bash profile. And so, you can put things in here like those aliases. It depends on where you want them. They could be in either one, but if you want to follow the recommendation of the sysadmin, I would do it what they recommend here, put aliases and functions here. I have a habit of making a .alias file that I propagate to different systems, and I have my bash rc launch and execute my .alias. And you use the source command. I don't know if we have an example for that. But this is where you truly customize your environment for what you want. And as long as you can't break the system too easily, you should be well sandboxed that if you're going to break anything, it's yours. So there's different kinds of shells: interactive login, interactive non-login, and non-interactive shells. So for example, when you log in, that's going to be it's an interactive login shell. So it reads and writes to the terminal. You can enter commands at the command line and see the output if you're in the interactive login shell. It's launched when you SSH in or when you launch a new shell. And that's usually where you do your work. The non-login shell, though, is launched from something like the batch system when you execute bash at the command line and you open up a new terminal. So the non-interactive shell is not associated with a terminal. There's no STD, standard in and out, and it's usually launched by a script. An example would be running jobs on the batch queue system. You use a batch script and it gets launched by the sbatch command. So in that script, you can treat it like a Unix script and set environment and variables that you want to have exported or pass them through the command line. And this is something that the complexity of a HPC system and all the layers of software and hardware and commands that you're running, especially when you're running a job from the batch queue, it gets really complicated knowing something's not working all of a sudden and what's wrong. And you have to go back and figure out which command that you were using where is not working right. So debugging. So then, understanding that is pretty important. So there's some order of execution, the order in which things get done. When you first come on, the system-wide files that just happen without you doing anything, and the sysadmin people and user support people work really hard to make these work and launch the right environment for the HPC system that you're on. And they aren't all the same, and so they're customized to whether you're on Expanse or TSCC or some other system out in the Access ecosystem, for example. So the interactive login shell, these get launched first, and then the system knows to launch .bash underscore profile, which will launch the .bash rc. Depending on Linux, you may or may not use these. I think on Expanse you use both of these. And so you don't have to worry about the orange, and be careful what you put into the blue. and make sure it's what you truly want. That, for example, we have recommendations on how to install and run your own Anaconda environment, and we don't recommend you put it in your local shell, your bash RC or bash profile, because every time you log in, it takes a long time to launch that environment. We recommend that you launch it separately with other commands. And so if you want to know how bash and bash RC work and bash profile, there's a link in here to sort of a web page that is hosted by the GNU environment people. Okay, so the good news is you get all this powerful information. The bad news, I would call it complex news, but the bad news is you have all this powerful configuration, but then the question is, where are you in this massive hierarchical system, and what shell are you running and how things get managed? So it's hard to follow sometimes, especially when you're launching a job that's running on the batch queue and it gets launched onto a node, and you can log into an interactive compute node if you've got a job running on it. But where are you in this hierarchy, and what are you launching, and what's your profile? Are you doing interactive, non-interactive? Linux configuration files can be very complicated. That's why you want to keep track of what you're using and isolate and make mini commands, alias things, so you repeat things that worked, and get us some habits for housekeeping and cleaning and just knowing where you are. And again, when I usually tell everybody taking a class from me is make sure you have Hello World, like a simple job that runs on the batch queue. And if it runs, a lot of this is all, okay, that's all fine. It's probably my code. Or a Hello World version of your code that if you run it should always run, even if you're making changes in more complex libraries. And then you know everything's working, but if you have a basic Hello World and it doesn't work, it's probably the system, and you would put in a support ticket. So kind of having that realization that it's complicated, though. We put this up here not to scare you, but we put this up here to show you my notifications, but sorry about that. But the good news is, if you're using bash and you're not a sysadmin, you just need to worry about these two files. But we show this to remind you that this is why we're doing this course, these complex presentations. This is really complicated, and you try and make it simpler by controlling your environment, but you may get completely confused, bollocksed up, and it's like, send a note to the consultant at sdsc.edu and ask them what's going on and what you might be doing wrong, and realize that you're not alone. And we appreciate at the beginning especially how challenging it can be to configure these files and add new things in that you need to do. If you have a colleague that you're inheriting work from, get as much of their bash profile and bash RC files as you can, for example. So use the bash profile. We recommend that you use them for commands that should be run once, such as setting up environment variables like the path. In the environment command, it prints out the $path, and $path is where usually all your binaries are. And if you have a binary you want to be seen first and run before other similarly named binaries, you want to put it in your path first. So $home so this path, you have $home.local/bin is a special binary directory in your home directory, and then you could run $home bin. So you're telling it anything in .local bin, run it, and if you don't find it there, then look in $home bin, and you'll see the same thing out in the sysadmin folders. Here is adding in the Anaconda 3 binary folder into the path, and then adding the path, an AMD profiler path. And then when you're all done building this path, export it so it goes into the environment. And don't edit this very beginning. Do not, that should be in bright red. This is built by your sysadmin user support team, and it makes sure that the right default system aliases and functions are loaded. So next are configuration files in the .bash rc. So that gets run for every new shell. And this is where you put things that you want customized to yourself when you get a new shell, like aliasing things and reservation aliases and loading particular modules. And in another tutorial, we talk about the modules. I don't think it's in this one. And modules are how you customize your user environment. And you want to load the Slurm and the SDSC that are useful for running jobs. Right, so I think we have the Expanse 101. If you want to know about modules today, I have a link to Expanse 101, which covers modules, and it's talked about in the Expanse user guide. But modules are a more modern way to make sure that the libraries you need for the particular application you're working with are in your path. So for example, if you're using one application and everything needs to be compiled with Intel, then you would set up the Intel module system. And then if you decide, well, I'm going to use the GNU compiler, and in some cases GNU compiles and runs better and faster than another compiler on the same system. It just depends on what your application is doing. But then if you want GNU, you would load in the GNU compile commands, and those are located in completely different folders, directories on Expanse, for example, and they're completely, you can't compile with one compiler and then compile with another and expect it to work. So you have to be real careful about building up the compilation configuration you want. Pseudo file systems. So the Linux philosophy, everything is a file. The distributions can provide pseudo file systems that allow you to access dynamically generated content. So it's using the same tools that you use to access the regular files. And they're normally found in the /proc folder. Remember /proc because in /sys, /proc/cpu info will tell you what's happening on the CPU for the node that you're on, like the login node as opposed to the CPU on a compute node. And it gives you, there's a lot more information. And you can tell, is it up, is it running, does CPU info. And so you can list what's in /proc as well. And sometimes it's important to know what CPU, because you may have a branch point in your software that needs to know what version, what model, etc. Lots of information that you might need depending on what you're working with. Or you're just curious. So pseudo file systems are pretty straightforward. And then there's bash scripting. That's going to take a while. It's something you'll be practicing on demand. But shell scripts they're programs that are executed by the Linux shell. They can be very simple, like echo $home is an example, or they can contain comments, commands, programming scripts like loops and do and while, build variables, save data, open files, read files, process files. They're pretty powerful, and they just need to be set as an executable. By tradition, .sh is a suggested way to identify that some script is a shell and it's meant to be an executable. And typically you want to put the shell at the top of it that you might want it to run. Otherwise it will run using the shell you're currently in. So make it executable using the chmod command. That's 755 is owner group world, and owner would be read, write, execute. This one would be read, execute, but no write, and this 5 is read, execute, and no write. So you have to give it the right commands. If you don't want the whole world reading and seeing your script, then these would be zeros. Then you can run your script with the // that says dot is the current directory I'm in, / means find something in it, script.shell, and because you've made executable, it'll run. Again, it doesn't have to be called script.shell, but it'll help you as you develop and do a lot of testing to know that, oh yeah, that's one of my test scripts. And this can work as well, .script shell. So we don't have time to go deeply into it, but we'll give you some examples. And if you can find all kinds of Linux script examples on the web, and they're fun to play with and help you learn a lot about the shell environment. So the first line here, this is pound exclamation point slash bin shell, and this is shebang. It's pronounced shebang. And so this tells it use the regular Unix shell. Here you could have bash, my favorite, Z shell, any shell that you want the commands to run under. And be aware that the different shells may have the same syntax for a lot of the commands and things you want to do, or the syntax may change. So be aware of what that shell should be and what you want it to be. And if you inherit it from somebody, then you may want to make changes. So here we're just going to execute and here's an echo, means print out this string, and it says first two lines of file1.txt, head -2 file1.txt, echo prints a blank line, and then echo the last two lines, tail -2, and then echo number of lines, pipe the file contents into word count and print it out. So here we're running simple shell, first two lines, line 1, line 2, last two lines, line 8, line 9, and there's 9 lines. So it's pretty simple. You should be able to copy this and make it work on any shell that you log into. Okay, and then you can do programming inside the shell, just like you do in Python or Fortran or C. So here is a for loop for file names in filestar.txt. So all the files get the file names. So this is basically ls filestar.txt. So this is a command. If I were to put parentheses around it, that command would be piped in, and we would pull the output from that command and get each file name and then do something inside. So we're going to do a word count on it, get the line count, and then we're done. And here we're going to do a file for every file in the output from this command here, ls-l file stars. Now we only want files that begin with file.txt, and we're going to list them in a linear format. Or we can do for x in all the files, count the lines in each of the files. And so notice this variable x and variable file and variable file name. You can call it whatever you want. I, A, B, C, whatever you want. But now we're going to run the loop for, it looks like the word count and then the file name. So both of these give the same output. Okay, and I think, all right, so shell scripts also process command line arguments, just like in other languages, with $1, $2, $3 storing the first, second, and third. $0 is the name of the script. So here we're going to print characters, word, and line count, and we're calling this counter.sh, and it reads a file. And word count will return the character, word-w, the line count, and we're going to cut. Cut will split the output on spaces and print the first field. So here we're getting the word count, get the characters, get the number of words here, and then the L will give us the line count. And so echo $1 contains, here's the name of the file, 180 characters, 36 words, and 9 lines. And then file 2 is a little bit different than file 1. So you get very powerful being able to pass command input. Most of the Unix commands that you run are doing something like this, and they're parsing the input and branching on the input arguments. And this one, we're going to capture the output to some other variable and echo this variables. And so here we get similar outputs. You can do if, else, if for the if construct. I notice we're a little over noon, and we are supposedly going to 12:30, so I'll try to wrap this up. And again, if some test in here, then do some arguments. The semicolon is really important. You can concatenate this to one line, but if, then finish with the fi means I'm finished, if, else, if, and we're done, and multiple elif, so we can do multiple tests. And then here's some examples that if $1 is less than $2, write that out. If it's less than $2, write something else out. So you can do quite a bit. And here we see comparing two numbers, less than, greater than, equal to, 2 is equal to 2. And you can have conditional statements. If with the comparisons done using ASCII order, integer literals are treated as strings in this context. So we're doing the same kind of thing here. And then here is conditional statement that if a file exists or is a regular file or is a directory, we do some operation on the file. So if this file exists and it's a regular file or it's a directory, print out this information. Or if -e fails, then the file does not exist. All right, summary. So we're at the end. We'll wrap it up. We're learning these intermediate Linux skills. They'll help you be more effective. Go to this repo where we have all of the commands you saw in the talk today are in a GitHub repository with a README file, and you can just cut and paste from those. And we haven't covered everything. We've covered what we feel is a good baseline. And if you want to do more advanced scripting and other tutorials, these are two recommended resources. And with that, thank you for your time and attention. And we're done.